So now we know that Rolle's theorem does apply for this function on the interval 1/4 pi to 3/4 pi. We said it was continuous. And we said it was differentiable on that interval. We also found that f of 1/4 pi was the same as f of 3/4 pi. But what we haven't done is we haven't found c. If the original function is the cosecant, the derivative is the opposite of the cosecant cotangent, whether you just use the formula or show it with the quotient rule. Our job is to set this derivative equal to 0 and solve. Now, of course, remember that we're only looking between 1/4 pi and 3/4 pi. Set this equal to 0. I would get a 0 if either the cosecant was 0 or the cotangent was 0, but only on this interval. Now let's think about what cosecant and cotangent are. So that is, again, we know that cosecant is the reciprocal of sine. We know that cotangent is the quotient of cosine divided by sine. If either of these is 0, okay, then we would get a product of 0. Now, if you consider this first factor, we want to know when will that ever be 0. It could only be 0 if the numerator was 0. But that numerator is -1, and it's never going to be 0. I'm not going to get a 0 out of here. My only chance of this being equal to 0 is from the second factor. Now, where will cosine over sine be 0? You can never let the bottom be 0. But that does happen wherever that numerator is 0. So our question is, where is cosine, or where is x going to be 0 between 1/4 pi and 3/4 pi? Well, however you do it, whether you have it memorized, you understand it, or you calculate it, the inverse cosine here is 1/2 pi, or 90 degrees. True, the cosine of 3/4 pi, 3/2 pi is also 0, but 3/2 pi is not on the interval. So, our only value of c, if you call it c or you call it x, where the derivative would be 0, would be 1/2 pi. And that's the final part of this question about Rolle's theorem.